So now it's time to turn our attention to the steps involved in starting a thread. We've already talked in the previous part of the lesson about the layers involved in starting a Java thread. Now it's time to start talking about the more detailed steps that are required. So there's a bunch of steps that are involved when starting a Java thread in a Java platform. We're going to use Android and AOSP, the Android open source platform, as the example of this. But be aware that the steps that are involved are very similar on other implementations as well. So the first thing we're going to do is let's assume we've made ourselves a class that extends from Java thread, such as mythread, and then we go ahead and make an instance of mythread, a new instance of mythread called mythread with a lowercase m, and we go ahead and start it. So that would take place, of course, at the application layer. When the start call is invoked, then under the hood, that calls the start method on the Java thread class, and that comes out, of course, of the core Java libraries that are part of the Java Lang package. So Java Lang thread is where those things reside. Now on Android under the hood, that then calls into another library, at least in earlier versions of Android, that would call something known as vmthread.create. And vmthread.create is no longer a Java method. It's a so-called native method that's written in C or C++. And you can look at the source code if you want to see what it looks like. Under the hood, the implementation of this, at least again in older versions of Android, are dalvik _Java _lang _vmthread _create, which of course is a Java native interface method written in C or C++. In this case, it's C++, but it could be in C. And then that further calls down to another method that's now coming out of the dalvik interpreter called dvm, for Dalvik Virtual Machine, create interp thread. So that's yet another level down. That's also a C++ implementation. And dvm create interp thread then finally calls into something that may be more familiar to those of you who've done a lot of C concurrent programming, which is pthread create. So pthread create is a POSIX pthreads method, which is going to create a thread using whatever resources are required on that platform to make a pthread, be it Linux or Solaris or some other platform, and it's going to pass in something called interp thread start. And interp thread start is an entry point function. It's really sort of a C function that's used to transition between C code, or C++ code for that matter, and Java code. So pthread create is a C function, and you can pass it either C function pointers or C++ static function pointers, and it basically provides a shim or a connection between these two realms. At this point, we're now into the Android Linux kernel, and I'm not going to trace the Android Linux kernel. That would go on and on and on, be very convoluted and complicated. But in a nutshell, what's going to happen there is that it's going to create a runtime thread stack and do all the other machinations required in order to get the thread up and running so it can go ahead and execute on an underlying processor core. And you can always get the source code for the Android Linux kernel if you're really curious to see what happens under the hood. At some point, the Android Linux kernel is going to call back to the function pointer that was passed into pthread create, which in this case is interp thread start. That's the one that comes out of Android in some version. And that's defined in this dalvik vm thread.cpp class. And that's basically an adapter that is going to bridge between the world of C, the cold, prickly, steely gray world of C code, and then the happy, warm and fuzzy Java object-oriented world. And the way that that works is that interp thread start calls dvm call method, and that passes in the actual object, which is the Java object. And then dvm call method will invoke the run hook method, which is that user-defined method that we have created and overridden in our mythread class. And that's where the actual user logic goes. We sometimes call that the business logic or the application logic or the service logic, depending on what it is that we're doing. So that was a quick walkthrough of the various steps involved in creating and starting a thread. I think you can see again that there's a lot of stuff going on here, and this stuff spans many layers in the underlying platform, in this case, the Android platform. But were you to look at the standard Java platform, you'd see pretty much the same layers done in more or less the same way with essentially the same overhead. So the consequence of all this is just keep in mind that spawning and starting threads doesn't come for free. There's an overhead associated with it. So you need to be judicious in how you use threads.